All right. Sorry. Okay, folks, good evening. All right, so we are continuing with the Jan 2024 Maths Paper 2. We got through the first 4 questions last week, Wednesday. So we are hoping to get through the next 4 today, which means Monday we can round off questions 9 and 10, as they tend to be some of the slightly more involved. I don't want to say problematic, but sometimes the more challenging questions, right? Hold on a second. Hold on a second. Right. I knew something was looking like it was too short. Yo. All right. Lucky for you, I have extra copies. Yeah.
Actually, you want me want to.
Right.
I think I need my cheeks.
Right. Okay, so like I said, trying to start on time today. I was very late with maths, so I'm trying to do the opposite here. Okay, so we're going to kind of tackle this paper in the same way. We're going to just kind of be walking through it, but I'll be asking you all stuff, giving you all time to work certain pieces, right? If there's anything you don't know outright, then that's okay, but you gotta let me know so I can explain it to you. I will be trying to explain things as I go along, right? Generally speaking, because that's what we're here to do, to get things explained so we understand better than before, right? But sometimes, sometimes we zone out. There's a Wednesday evening, carnival just finished, what's going on. And don't forget, we are basically 9 weeks out from the exam, right? So we have, that's what, 63, maybe 65 days. So we have things to do, right? So don't panic, all right? We have time, but you have to work with the time you have. Okay, with that being said, let's proceed. So it says that the mass M in kilograms of 120 newborns at a hospital is recorded in the table below, right? So what do we call this type of data? Is this raw data, ungrouped, or grouped? So raw data would be where they present each and every single value. Ungrouped would be where they give you single values and the frequency. As you can see here, what are these things called again? Those are called class intervals, right? So where they give it like if it was like 1 to 10, 11 to 20, that kind of thing, those are called class intervals. So these items here are called class intervals. All right. And yes, as Paige correctly said, this is also called grouped data, right? So this is grouped data. Right? And these things are called class intervals. Boy. Solo some dust from Panorama. Going on. And I got a water on the truck. All right. So we have mass. So the ranges go from 2.6 to 3.5, 3.5 to 4.4, 4.4 to 5.3, etc. Right? Now, what is the frequency in this particular context here? What does that mean? The frequency is the number of readings that falls in that particular class interval. So in the interval 2.6 to 3.5, 7 readings or 7 data points fell there. But the thing is, we don't know what the exact values of those data points are. We don't know if there's like 2.7, 3.2, 2.9. They could all be 3.0 for all we know, but we don't, right? So grouping data helps us summarize the data to make it a bit more easily presentable. But in doing that and making it more easily presentable, we sacrifice a level of detail, of specificity, all right? Sorry, that's Manishi playing outside my dad. Anyhow, right, so 7 readings fell into the first interval, 18 in the second, etc., right? Now, when they talk about the modal class, what is the mode, generally speaking? The most frequently appearing data point. Let me just let in D'Angelo here. Hey, D'Angelo, good evening. How you doing? Good to have you on. Home the carnival was good. Right, so actually my role. So D'Angelo is here, Donovan is here, Juliana, Hanifa, Jaziri, Jolie, Khalifa, Nyla, Paige, Zian. Right, okay, cool. So that's 10 out of 20. So that's half the class, right? What? All right. Okay. So yeah, so the mode is the most frequently appearing data point, right? So for example, if I gave you some raw data, okay, hold on, just now what's going on there? Come to you, just so. Okay, that's all. It blinking back out to come back in. If it keeps doing that, I'm gonna just switch the codes. Okay, it back up. Yeah, all right. Yeah. So let's say. All right, so let's say I give you this group of data on top here. 1, 2, 3, 3, 3, 4, 5. Which of those items is the most frequently appearing one? Which one appears the most number of times? The 3. That's the mode in that data set there. Right. Now, again, we don't have raw data here. We have group data. But the mode also applies to the biggest frequency. So what is the biggest number in the frequency column? 30. And what is the interval in which that applies to? The 4.4 to 5.3. So state the modal class, so all we have to do is state 4.4 less than m less than equal to 5.3. Cool. Yes, on. Right. Okay, cool. YouTube vibes. All right, so that is the modal class. Now it goes on to say, complete the table below and calculate an estimate of the mean mass of the 120 newborns. So that word there, that thing, an estimate, right? Now the mean, what does that word mean? That is correct, that's the average, the arithmetic mean or the average. So you add up all the individual values and then divide by the number of values, right? But again, what type of data are we dealing with? Hey, Preet, have you heard it? We're dealing with group data. So we do not have all of the individual values, right? So what they've done here is they've given you, so this table above here, this is the same first column. They've given you a midpoint now, and then they've given you the frequency. And what they're doing in the fourth or rightmost column, yeah, is they're multiplying going across. So 3.05 by 7 is equal to that. 3.95 multiplied by 18 is equal to 71.1. 4.85 by 30 is equal to 145.5, sorry. All right, now, hold on, let me just look at Aisha here. Hey, evening Aisha, how you doing? Good to have you on, hope you had a good carnival. Yeah, I saw something with the, like you left the PUE and the maths groups. I don't know if that was maybe, I know you sent me an access to your phone. Anyhow, but good to see you. We're working the Jan 2024 maths paper 2, question 5. We didn't start too long. All I missed so far was the identification of the, the modal class. All right, so now we're working on an estimate of the mean or average mass of the 120 newborns. Right, so check this, right? If I gave you again 1, 2, 3, 3, 3, 4, 5, right? And I asked you to find the mean of that set of numbers, what would you do? You'd add up all the numbers and then divide by how many they were. So 1 plus 2 plus 3 is 6. 6 and 6 is 12. 12 and 4 is 16 plus 5 is 21. How many numbers you have? 1, 2, 3, 4, 5, 6, 7. And 21 divided by 7 is exactly equal to 3. So 3 is actually the mode, it's the mode, it's the most frequently appearing data value. It's the mean, the average of all of them. And it's also actually the median, the value exactly halfway in the distribution. That's the same number of data points before it and after it. All right. But anyway, that's how you'd find the mean if you had raw data. You add up all the individual data points and divide by how many data points exist. If we had on group data, so for example, so let's say that the X values, right, which is 1, 2, 3, and 4, right? So let's say people were asking how many kids each family has, right? So the X was the number of kids in the family, and the F was the number of families, the frequency, the number of families that had that number of children, right? So let's say 9 families had 1 kid, all right? 12 families had 2, all right? 6 had 3, and 5 families had 4 kids, right? So what it's saying here is when they did the interviews, they had 9 ones, right? So that's what this means, right? If you have a value of 1 with a frequency of 9, it means 9 families had 1. So if you to write it out raw, you'd have to write out 9 ones, then 12 twos, then 6 threes, and then 4 fives, right? And if you had to find the average or the mean, what would you do? You could add up all of them raw. Or was it shortcut for adding 9 ones? Multiplying 1 by 9. So you can multiply 1 by 9 and you get 9. You can then multiply 2 by 12 and get what? 24. You can multiply 3 by 6 and get 18. And you can multiply 4 by 5 and get 20. And you can then add 9 and 24 is 33. 33 and 18 is 51. And 51 and 20 is 71. And then you'd have to find the number of data points, which is as simple as adding the frequencies. 9 and 12 is 21. 6 and 5 is 11. 21 and 11 is 32. So then we have 71 divided by 32, which is a little more than 2. 2 point something. Right? Because 2 by 32 is 64. So almost 2.25, right? But of course, I mean, you can't have 2 1/4 children, right? So you round it to the nearest whole number, most likely. All right? So that's if you had ungrouped data, right? So you'd have each individual value and the frequency of the values, right? Well, now when you have group data, we don't have the individual values. So what happens there is that we have to create an estimate, right, of all the individual values. And that's where the midpoint comes into play. So what the midpoint is you'll take this, you'll take that, what we call the upper and lower class limits. You're going to add them together and then divide by 2. So 2.6 and 3.5 is 6.1. And 6.1 divided by 2 is 3.05. And that's how they got the 3.05 here. It's simply the average of the upper and lower class limits. This is the lower class limit is the lower value in the interval, the smallest value in the interval, and the upper class limit is the highest value in the interval. Sorry, right? And that's how they got these values here, 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 and here. Now, after we found the midpoint, well, what is the point of finding the midpoint? Because again, we do have the individual values. We don't have what each of those 7 values is. We don't have the actual exact numbers, right? So what we do is we use the midpoint as a representative value of all of the individual values. So instead of like in the example, just not like you multiply, it was the 1 by 12 and 2 by 9 or whatever the case was. You're going to multiply this by the 7 to get that, right? So you're taking the midpoint in each case and multiplying it by the frequency to get that piece there. So what I want you to do for me is I want you to find this midpoint here, and then I want you to multiply it going across to get the value in that column there. All right, 57.5. What is that for the average? I'll let you know in a couple of minutes. All right, right. So again, what we're doing here is we are using this table to calculate an estimate of the mean mass of the newborns. Why an estimate? Because again, as we said, with group data, we don't have all of the individual values, right? We just know that 7 values lie between 2.6 and 3.5. 18 lie between 3.5 and 4.4, and so on, right? So what we do is we find the average, or the midpoint rather, of the class interval, and we use that value to multiply by the frequency, right? So, and again, there's no guarantee that this value here properly represents each and every one of the 7 values inside of here, right? For all we know, all 7 could have been 3.5. We don't know. Or all 7 could have been 2.7. We don't know, right? So that's why it's an estimate. We're just saying, right? So what time do you rely for maths? Usually between 6:30 and 6:45. I started a bit on time today because I started very late for POA, so I wanted to not have that happen for maths. Right? So yeah, to find this piece here, you're taking this, you're adding that, and dividing by 2. To find this piece here, you're taking this, you're adding that, and you're dividing by 2. Yo. Okay. Which part of number 2? There's a difference in 2 squares. Look at the green off to the right there. Yeah. Right? Make sense? About 5.57. You could give me a name. I don't know what the symbol is. I want to refer to you properly. Thanks. Okay, we're gonna go back. I think. Eggs Benedict boy. Yo, what? Okay, no problem. Right. So let's find the midpoint for those two values there. So we're gonna take 5.3 and 6.2. We're gonna add those together. 5.3 plus 6.2 and divide that by 2. So 5.3 and 6.2 will give us 11.5, I believe. Yeah. That's 5.75. Let's double check that with the calculator. All right, 5.3 plus 6.2 divided by 2. 5.75. Right. And then for the other one below there, right, so that's 7.1. Sorry, I should probably pull that down. So it's kind of in line with that item there. Okay. Right. Then we have 7.1 plus 8.0 all over 2. Right. So that's 15.1 all over 2. So that's 7.55. Let me see. 15.1 divided by 2. Yeah, 7.55. Yes. That's is it Yana and Kelly? There you go. Good job. Yeah, 7.55. Any interaction. Thanks, guys. You have nobody. One viewer. All right. And now we're going to multiply going across. You're going to multiply 5.75 by 29 and 7.55 by 8. Well, that one easy-ish. That's 56. That's 60. 60.4. Yeah, 60.4. 5.75 by 29, boy. All right, so what's 5.75 by 28? Because we could find 3/4 of 20. So 28 by 5 is 140. 3/4 of 28 is 21. All right. 140 and 21 is 161. 161 plus 5.75 is 166.75. Let's see. $166.75. Yeah, there you go. See, if you work your brains, stay in good shape. Okay. Aisha, D'Angelo, Donovan, and Julie, just kindly give me a quick G if you guys are good with what I've done so far. Okay. Right. If you need me to re-explain anything, please give me an R. Let me know what I can help you with. Thank you, Aisha, Donovan, Julie. All right, cool. D'Angelo, all right. Oh, yeah. You can send me pics on WhatsApp. The notifications coming up, right? Because they dinged off a couple of times. All right. Noah R. Have a particular part, Noah. Is there a specific part you meant to go over? Right. So while Noah talking to me. Right. So what I want you guys to do is I want you all to add up the values in this column here and in this column here. You get the answer for frequency midpoint. Okay, so the frequency midpoint or frequency by midpoint, you multiply. You're multiplying the frequency by the midpoint. So 7 by 3.05 is that. 18 by 3.95 is that. All right. Okay, hold on. Abriel, I think I answered Abriel. You always divide by 2. If you find any midpoint, yes. Yana, what time do you start? Between 6:30 and 6:45. Rihanna. Sorry, did I miss your question, Rihanna? You all not hear me? Oh, okay. Monday and Wednesday. Coming here to exams, it might be a little more. All right. Okay, cool. Okay, 7 and 18 is 25, 25 and 30 is 55, 55 and 57 is 112, 112 and 8 is 120. But we kind of knew that because it told us it's 120 newborns, right? 120 and 651.3. All right, cool. So who's that? Kelly give me a nice total there, boy. All right, 21 and 71 is 92, 92 and 145 is 237, 237 and 166. 403. 403 and 186 is 589. 589 and 60 is 649. So close. Okay. 649. Okay, cool. So then 649.95, 649, 650, right? So 650.7, 651.3. Yeah. Yeah. Right. And now to find the mean, or the mean, right? So if you want like a little formula or some symbols, right? It's the sum of f by x divided by the sum of f, right? That kind of weird E-looking thing is sigma. It's actually an S. There's another version of it, like looks like this. And then the add math students will recognize that as an integral sign because integration is a fancy form of summation. Sorry, right? So you'll take your 651.3 over 120. Sorry, now 120 by 5 is 600 exactly. So that's, and then 120. That's 5/12. All right, I just gonna divide it because could you? Right. 651.3. You went on a heel panorama dust, it's sticking in your throat. What's going on there? Who's listening again? We partner? The partner's not your partner? Sure. All right, cool. 5.4275. Right. Yeah, so you can do 5.43 because, like I said, there's a standing instruction to the front of the page that says when answers are not exact. Well, actually, this is actually exact. You could do, yeah. So I think you could give this answer, and this is in kilograms, right? Right. Or you could round up to 5.43, which is the three significant figures. Okay. All right. Okay, cool. So Google Meet, right? I should on the run, Julie and D'Angelo. Just give me a quick G if you're good with how we finished off the question to find the mean. All right. Please and thanks. If you need me to re-explain them, I know. All right. All right. So Zian, Jaziri, Naila, and Paige, you okay with that? I see or hear Zian. Zian, talk to me now. Good? All right, cool. Thank you. All right. Donovan, Aisha, D'Angelo. All right. Julie, talk to me. All right, I'm my ladies on this side. If you have any questions, that was a good time. Are you playing? Or no? What's going on here? I seen phones and taking pictures of pictures. Are they playing to me? Did I get what continuations go? Oh, all right, cool. All right, well, cool. Next time I'll give me the answer. All right. Any questions? Sure. Okay. All right, so we're going to the next page. Let's go. Actually, hold on. Hey, behave yourself. Right, give me a sec. I have no idea if this is in focus. Right. Okay, cool. Let's check out 5B. So it says one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms. Okay, so we want the probability that the mass M is greater than 5.3 kilograms. So what we need is the number of babies who have a mass of greater than 5.3 kilograms. So the N is the number of babies, right, who have a mass greater than 5.3 kilograms. Sorry, one sec. Oh, okay. And we're dividing that by the total number of babies in the survey or sample space, right? Now, we know that that denominator is 120, yeah? So now we have to go to back to the table and take a look and see how many babies weighed more than 5.3 kilograms. So let's go back to that table. We're gonna have to zoom in. Hey, behave yourself. Oh, you reached there now. Behave yourself. Right. Zoom back out and zoom back in. Okay, we could go up here to the first table. Okay, let's take that out, shall we? Okay, so I see in 5.3 here, right? But the symbol next to it says less than or equal to 5.3. Do we want less than or equal to 5.3 or greater than 5.3? What's in there? Oh, okay, thanks. Right, so everything here kind of out. Now you could use that to help find the answer, right? But it means that every section above that, the baby's weighing more than 5.3. As a matter of fact, if you look here, the first piece of this says what? That M is greater than 5.3. So how many babies are in this interval here? 29, right? How many in this interval? 28. Now 29 plus 28. So you gotta add that. You gotta add that. That'll give you 57. And then in the last interval, you gotta add that too. So 57 plus 8 will give us 65. Right? And why am I adding these three numbers? Because these three numbers tell me how many babies are in each of these intervals. And the babies in these intervals all have a weight greater than the 5.3. And that's what we're looking for. All right? So we call it the CF column, the cumulative frequency column. All right? So 29 and 50, sorry, so 29 and 20 is 57. 57 and 8 is 65. So what we do is you could take 65. Oh, come on, man, Philip, give yourself. Hold on, huh? Okay, well, it have plenty space. That space like NASA. There we go. If you're cool, you can let me know. I can fix the AC temperature. That too? All right, cool. Go sit down and freeze. Let me know something. Oh, come. All right, hold on. Just now. Give me a second. It's gonna blank out, but I'm connecting it with the cord that hardwires it. It's connected to a hub, and the hub's supposed to do the feeding, but something going on with the connectors in the whatever. Right. So we have 65 babies out of a total of 120, and those 65 weigh more than 5.3 kilograms, right? So all we have to do now is divide. So 65 divided by 120. So if it was 60 out of 120 would be what? 50%. That's half, right? 65 is more than half. So a little more. Let me see. So 54.1. Okay, cool. So you could put that as 54.1% or whatever the case is, right? Or you could even just reduce it, right? So that could be simply 13 over 24. That could be your answer, right? You don't. What? Hush. Right, sorry. Yeah. So you could give it as a percentage, you could give it as a decimal, you could give it as a fraction. All right. So in this case, 13 over 24 is fine. If you did plug it in your calculator and you got the 54 point blah blah blah, then you could put that too. 54, you could put 0.541, you could put 0.542, right? Or 54.17%. All right. So you can express a probability in percentage form. Right, so that would have been 54.17%. The two decimal places, you could have put in decimal 0.542, or if you want to be at 0.5416 and put a dot over it to indicate that the 6 repeats infinitely, right? Or just 13 over 24. That's the probability, right? So a little more than half, because 12 over 24 would be exactly 1/2. All right, okay. And let's go down. So complete the cumulative frequency table shown below. Right. So cumulative frequency is simply the sum of the frequency from one level to the next. Everything all right? So, what's that? Oh, well, tell me that. What, you want to see this piece here? Don't tell me. If you need me to slow down, that's not a problem. I mean, it's not about me blazing through the paper. It's about me explaining the stuff and working through. So if I'm going too fast, let me know. If you had to see something again, that's not a problem. Let me know. I'm sure somebody else probably want to see this thing and go shy, you know. All you had to be shy with me. There's some water. Well, you're not a tree. You can move. All right. So the CF table down here now. Sorry, 1 second. Right. So to accumulate means to build up or to add up, right? So what I'm going to do is I'm just going to pull the individual frequencies. If the, right. So 7, 18, 30, 29, 28, 8. All right. So 7, 18, 30, 29, 28, 8. So all you're going to do to get the CF values is simply you're adding like here, across and down, right? So 7, 18 was 25. 25 and 30 was 55. So I want you to finish off that CF table, please, right? HYMC share the life. Thank you, HYMC. Appreciate it. That my mask crew. That them, the them that is the they. Right, speak. Right. I'm glad I see calculators out. Because mock coming up here, guys, and you can't go any exam with your phone. Right. I think when she's in 84. All right, cool. And Yana. All right, cool. Let me see. 4. Should it be 120? Oh, you mean the next line? Yeah. 55 and 29 is 84. I could agree with that. Cool. Right. 120. Last one. It's smiley. Yes, there you go. Good job. 112 and 1. All right, lovely. Right. 84 and 28 is 112, and 112 and 8 is 120. Right. So that's the CF. Now we have one more piece to go, but before we go into that last piece, right? Let me just send a picture of this page in the chart. Chat. Crop out some edges there. That's me. Okay, ladies, we okay with that page there? Any questions? We good? All right, cool. Far side. All right, so Zian Jaziri. Yeah? All right. And Aisha, Donovan, D'Angelo, and Julie. Just give me a quick G if you're a good day. If you need to re-explain anything, let me know. Use on songs. Yeah? All right. All right, hold on. Oh, let me see. Can I go over the key? This is the Jan 2024 paper too. But we kind of finished this PCD question. Okay, B. Sorry. You can always check the replay it on YouTube. Right? The replays will stay up for about a day or two. If you're lucky the weekend, but I can't promise the whole weekend. Right? So yeah. Yeah, miss much. There's only one question we're doing so far. Trying to accelerate the pace, but again, trying 2024. And 2024. You. All right, cool. Okay. Page number one, right?
Yeah.
All right,
I
cool.
was gonna write it
Okay. Aha. CF curve time boy. On the grid below, draw a cumulative frequency curve to show the information in the table in B part 1 on page 60. Okay. So a cumulative frequency curve is a visual representation of the grouped data, right? It looks something like this, right? Again, something like, it could look like that, all kind of thing, right? And from that, we could use that CF curve to estimate medians, the quartiles, the interquartile range, the semi-interquartile range, all that kind of stuff, right? You'll notice on the horizontal or x-axis, they have mass, the variable that was being measured, all right? You'll also notice they don't start at 0 on the horizontal, right? The 0 there is for the vertical. And on the vertical, they have the CF, right? So that's why they made us do this table here just now. Right, so they want us to plot. So basically what they did is they put in the first couple for us, right? So let me explain what I mean by that. So you have your 0 and your 2.5 because you kind of have to start at the origin for the most part, right? Now, the first thing they would have plotted would have been the 3.5 on the X and the 7 on the Y. So let's take a look there, right? So if we zoom in, right? So let's just examine the scale on each axis first, right? So from here, they go from 2.5 to 3.5. That's 1, right? And if you notice, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So you're dividing 1 into 10. So it means each of those spaces is a tenth. So like this is 2.5 here. So when you go up in tenths, you get 2.6, 2.7, 2.8, 2.9, 3. And you have 3.1, 3.2, 3.3, 3.4, 3.5. So that's how they went across on the horizontal axis. On the vertical axis now, right, what they did was, if you note, you have a 0 to a 10. So that's 10, as a count of 10 in the same 5 spaces. So 10 divided by 5 is how many? 2. So each of the little boxes there is a 2. So you have 2, 4, 6, 8, and then 10. So it goes up in 2s and across in 0.1s, right? So the first item, the first pair of terms, the first pair of values, first pair of corresponding values was 3.5 on the X. So this is the X axis here, and it's the Y axis, right? So, sorry, it did it again. Did it blank off? Yo. Yeah, I'll show you how to do the graph, yeah. No, yeah, I switched back. Because I have to pull the values from there, right? So yeah, so the 3.5 on the X and 7 on the Y. Okay, cool. All right, so 3.5 on the X. Now, to get 7 on the Y, so again, this is 2, 4, 6, 8. Did I count that right? Or did they have it in the wrong place? They do. They do have it in the wrong place because look, if you're going up, right? This is 2, this is 4, this is 6, and that is 8. And 7 lies between which one? 6 and 8, not so? So 7 should actually lie here. What they marked off here was between 4 and 6. And what's between 4 and 6? 5. Right? So what we're going to do, let me see if I can just blank off this item here. Oops. And I'll see if I could redraw a little line there. Oh no, that is way too heavy. Oh, I forgot I zoomed in, so that's why. Okay. All right, so that's how we got 7. So that pink dot is 7 and 3.5, right? Okay. Well, the next one I see in there. So let's go back to the table of values. Right. So the next one is sorry, where did that come from? Right. It's 4.4 on the X and 25 on the Y. So let's see what happened there. So 4.4, right. So 4.4 is that line. And 25. So that's 20 here. So that's 22, that's 24, that's 26, right? And that's exactly between 24 and 26, which is 25. Okay, so this item here is in the proper place. Okay, cool. Right, so don't forget we also started from 0, 0. So we're gonna just kind of trace our lines. Now, they gave you the first two. So what they want you to do is to plot the rest. So now you have to go and plot the 5.3 to the 55, 6.2 to 84, 7.1 to 112, and 8.0 to 120, right? So for those of you in class, you'll have the graph. So see if you can plot those. Those of you not in class and don't have the graph, see if you could sketch one now. I mean, if you have a graph page, sorry, by all means. Which question is this? This is question 5, part B. In the Jan 2024 paper 2. Unique. Yeah. Okay, cool. Yo, Jadon, right. Are you teaching lessons right now? I am. That is correct. Welcome to tag along. We're doing some past papers. Right. All right. Okay, so let me see. So we had to do 30 to 55. Sorry, 5.3 to 55. All right, 5.3 on the X to 55. What are we doing? So sure no. Jan 2024, paper 2, question 5. We're doing a CFQ, right? So 5.3 to how much? Sorry? 55. Okay. So 5.3 on the X would be this line here, right? All right, and this is 52, 54, 56. So 55 would be exactly between 54 and 56. Right, so we're looking at somewhere around there. 1 second. Yeah, somewhere around there. Okay, now let's do. Right, sorry. Give me a second. Right. So now we're doing 6.2 to 84. Let's see. 6.2 to 84. So 6.2, 6.4, 6.2 be about here. And 84 is the second line above there. We get a nice flush thing there. Cool. Okay, now 7.1 to 112. 7.1 on the X, so 7.1 is about there. And then 100 actually 112 is exactly where it ended, so right there. Okay, cool. And the last one is 8.0 to 120. Okay, cool. 8.0 is that middle line there, and 120 is right at the top. Okay. So now we have to connect those points with a smooth line, which to me is the hardest part of this bloody thing. So I actually start from the top and come down. So as you can see, my line is not smooth in the least. Yeah, my line looking like it have gingivitis. I don't know. Something. But yeah, if you could do a better line, then please do that, right? Also, when you're doing your line, make sure the point is not too thick. It's not too heavy a point, as in like it's not easy to erase. If you need to erase, you should be able to do so easily, right? And if you erase too hard, you could actually erase some of the print on the paper and create difficulties for yourself. All right? Really? That's interesting. Very much so. You know, that's interesting. Q is the frequency. Right, there we go there. Right. So that's the curve. Now, what else did they ask us? Use your diagram to find an estimate for the median mass. So the median, right? It's the median. What is the median, right? So the median is the exact halfway reading. Now, how many readings we have? We have 120 readings. What is halfway? What is the halfway point to 120? 60. So what you do is you go to 60 and you read across till it hits the curve, and then you read down. And that there is the median weight, which is what? 5.5. Right? So to find the median, you're going to take your n, which is the number of n or f, right? And the number of readings, or f, the total, the CF, you can take CF, cumulative frequency, and then divide by 2, right? Now that's not going to give you the value of the median, right? That's going to give you the place of the median. So the 60th reading is the reading of the median. And you're going, this is the y value. And the median is the x value. Right, which is 5.5 kilograms. Right, and again, this is an estimate because again, the way you draw the curve could differ slightly from person to person, right? So they'll create a range of acceptable values for the median. Yo. That's okay? Yeah. All right. All right. So Google Meet. You know the drill. So Aisha, Donovan, D'Angelo, Julie. If you guys are good with the curve, just kind of give me a quick G in the chat. If you need me to re-explain any particular aspect of it or the median calculation, then please give me a G and give me a R and let me know, right? If you're good, G is fine. Okay. Yeah, Nyla, Pedro, you okay with the graph and the median? All right, cool. All right. Okay, Shona, good. All right. Jolie, Khalifa, and Hanifa, are we okay? What's on the screen there? Any questions? Anybody? Anything? No? All right. All right, so I'll give you a minute or so if you're copying it down. And now we're going to go on to question 6. So I'm not sure how we spend an hour on that, but well, about 45 minutes. But again, it's not the point is not to speed through the whole thing. Spend so much time on it, to be honest. To the median. Yeah, Kelly, talk to me. To the median. When we spend time on the median, that's what I mean. Meet her. Art now. Okay, moving along. Right, we'll come back to any questions now. So now we come to the measurement part. Can you go back to the calculations to the median? Oh, right. So all you do is you take n, where n is the total number at the top of the CF, right? Well, the total frequencies. You divide that by 2 to get your halfway point. But that value is the y value. That's this value here. You read across from the y value to the curve, and then you read down to the x-axis, and that reading there is the median, right? At least I hope that helps. Okay, so number 6. In this question, use pi as 22 over 7, right? So that's Archimedes' upper bound of pi. Question, diagrams below show a we're on the screen, right? The diagrams below show a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12 centimeters, and the height is 17 centimeters. So that's the cylindrical tin there. Diameter is 12, and the height is 17. All right. This is a hemispherical bowl, which is like any regular bowl you might have at home, right? A hemisphere means half of a sphere. So a sphere is like a ball. If you cut the ball in half, right, you get a hemisphere, right? So you have a radius here, and of course this is a circle, and they've given us the diameter. If we had to find the radius, from this diameter, how do we do so? The diameter is equal to 2 times or double the radius. So how would I find the radius if I have a diameter? Divide by 2, right? So you divide by 2. Cool. All right, now show that the volume of the cylindrical tin is that. Correct the 4 significant figures. Okay. Divide by 2. Very good, Kelly and Sean. All right. So if you don't know what the volume of a cylinder is, the volume of a cylinder is equal to pi by r squared by h, where h is the height and r is the radius, and of course we have diameters, and we now know what to find. So I'll give you guys a minute or two, right? Put in the values, and they said to use pi as 22 over 7, eh? But let's check to make sure, right? So 1, 2, 3. Anyhow, see how best we could do it. That. Right. So they said use pi as 22 over 7, right? So 22 over 7 multiplied by r. So if diameter is 12, r is 6. Height is 17, right? So again, you can just plug this into a calculator and spit out a value. All right, so we'll have 22 by 36 by 17, right? And then divide that by 7. Oh, yeah, see, 1923.4, blah, 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 but it said just to 4 significant figures, right? So yeah, so this is approximately equal to 1923 cubic centimeters, right? I'm not sure whether that is 2 marks, but okay. Okay, now it says the bowl is completely filled with soup. So this is the bowl here. And when all the soup is poured into this empty cylindrical tin, only 90% of the volume of the tin is filled. All right. So let's just unpack that. If the bowl is completely filled with soup, what percentage of the bowl is filled? Completely filled means how much percent? 100%. When you pour 100% of the volume of the bowl into the cylindrical tin, you only fill 90% of the tin. So it means that the volume of the bowl is 90% of the volume of the tin, right? So that's one thing we got to. So hold on, put that in green, right? So volume of bowl is equal to 90% of volume of the tin. Are we okay with that observation? Right, yes or no? You know? If there's no, then never know. All right. So the bowl is completely filled with soup. Completely filled means what percentage? 100. So if the bowl is completely filled, it's 100% filled with soup. Agreed? Okay. And when you pour, when all the soup is poured into the empty, so when you pour from here into here, right? Then notice it don't go all the way up. It stop about here. And that is 90% full, right? So what we're seeing is that if you take all the soup in the bowl and pour it into the tin only fills 90%. So what that means is that the volume of the bowl is only 90% of the volume of the tin. We okay with it now? Right. So that's the observation in green. The volume of the bowl is equal to 90% of the volume of the tin. Now look what they want you to find. Calculate the radius of the bowl. All right. Now, the bowl is a hemisphere. Right? It's a hemisphere, which is half of a sphere. I want to give you down here the volume of the sphere, right? So if this is the volume of the whole sphere, how do we find the volume of a hemisphere? Divided by 2 or multiplied by half, right? So check it. You have a couple of layers here to dig down in, right? They want us to find the radius of the bowl. The shape of the bowl is a hemisphere. A hemisphere is half of a sphere, right? So the volume of the bowl is equal to 1/2 of this, right? Because it tells us that the volume of a sphere is that. So the volume of a hemisphere should be half of that. And on top of that, the volume of the hemisphere, which is the bowl, is equal to 90% of this. All right? So what you could do is find 90% of the 1923. That'll give you a value that you can put on the right-hand side of the equation. And then put this equal to whatever that is and solve for R. Okay? So, right. So, like I said, this is where they're trying to catch people here. And you had to take it step by step, piece by piece, right? And for that one, it's 3 marks, eh? So, you know, you have a little bit of work to do. Right. So, like I was saying, if you find half of 4/3, 2 we cancel with 4 many times? 2, right? So, you have 2/3 by 22/7 by R cubed is equal to 90% and 90. Okay, what was that? Multiply by 0.9, 1731. I'm going to double check that. Yeah, so there is 1731, right? Okay, so using this, I want you to solve for R. Try it. All right, so I'll give you a minute or two. If you need any guidance, let me know. There's no problem. but I want to give people at least a minute to kind of think through it. Get at least one line down the line. All right. No problem. Still cool? Truth. Still cool. All right. 1 second. Oh, all right. We're good with that. We're good. Okay. Not bad, man. A little bit too ET. Uh-huh. Sorry, Zine. I'm not seeing. No multiple by pi. Yeah. 22/7. Okay. So the volume of the bowl, which is a hemisphere, right, is half of the volume of a sphere, which is 4/3 pi r cubed. And we know, because they told us so, that that's 90% of the volume of the cylindrical container. Tin. Okay. So we found 90% of that, gave it approximately 1731, right? They'll give you a range of values you could use, so you could round off. Right. Now, check it. When you multiply in fractions, what do? We multiply numerator by numerator and denominator by denominator. So 2 by 22 is what? 44. And 3 by 7 is 21, right? That real close to 44 over 22, which is just about 2, eh? Right. Now, check it. We want to solve for r. Right now, what is connected to the r? Right now, the r is being raised to the power 3 and then being multiplied by this. To remove this item, you have to use the opposite of the operation and attach it. What is that operation there? And to remove something as a multiplication, what do? We use division. And of course, whatever happens on one side of an equation must happen on the next side. Now, when we are dividing with fractions, what's the protocol? We change divide to multiply and invert the divisor. So we're going to multiply by 21/44. Now we're going to come up here to continue. So r cubed is equal to, so 1731 by 21, that's 36,351. So 36,351 all over 44. And now that's r cubed. All right, let's take a look. To find r, you have to undo the cube. How do we undo a cube? You have to find the cube root. All right, so let's see. So that then divided by 44, and then with a cube root that. So we get about 9.38 about cube root, not square, cube root. R is approximately equal to, did they give us about 9? Now they said usually 3 significant figures, right? So 9.38, right? So R is equal to 9.38 centimeters, correct to 3 significant figures. That makes sense. Okay, glad. All right. Okay, so once again, just to recap what we did. Yeah. Right? So it says that the bowl is completely filled with soup. Completely filled means 100% filled. When all the soup is poured into the cylindrical tin, 90% of the tin is filled, right? Okay, cool. So the volume of the bowl is 90% of the volume of the cylindrical tin. All right. Just Aaron. Adding and subtracting. You can do that too. Right. Zine, the stats. Which part of the stats, boy? No, no. I really don't understand. Let me see. Okay. So again, just a recap from the top, right? Hold on. What's 6b? Okay, right. That's fine. So the first thing they gave us to do was to find the volume. To find the volume of the cylinder, right? The volume of a cylinder is pi r squared by h. They said to use pi as 22/7. The diameter of the cylinder was 12, which means that the radius was 6. Right? So pi r squared by h, so you put 22/7 by r squared, which is 6 squared, and then by h, which is 17. Zine, how to look for that way? DM me on Instagram now. I'll see if I can help you. But I'm not sure. Yeah. So you plug it into a calculator and they actually gave you the value here, right? Now they then told you that when the bowl, as in this item, oh, come on, man, Philip, give yourself, right? So when this item here is completely filled with soup, so completely filled means 100% filled, and then all the soup is poured inside of here, it only comes up to about 90% of the way, right? It means that this here is only 90% of the volume, which is 90% of this, right? Now, on top of that, this is a hemisphere, and a hemisphere is half of a sphere. Now, they gave you the formula for the volume of a sphere, 4/3 pi r cubed. That's the formula. They gave it to you, right? So if you want the volume of a hemisphere, you have to find half of that, because a hemisphere is literally half of a sphere, right? So the volume of the bowl, which is the volume of the hemisphere, is equal to 90% of the volume of the cylindrical tin, right? So again, you just plug in, you substitute your values into your equation, you simplify, and you solve, right? If the solving is the aspect, then let me know, right? So yeah, so a half of 4/3, the 2's will cancel with the 4, you get 2/3, right? And then pi was 22/7, right? So 2 by 22 is 44, 3 by 7 is 21. And then to solve for r cubed, you're going to move the 44 over 21 by division. And when you divide by fractions, you change divide to multiply, and you invert the fraction. We get this. And then to solve for r, you have to undo the cube. To undo a cube, you have to find the cube root. Right? And when you plug it into your calculator, we get approximately 9.3. Okay. All right. So Aisha, Donovan, D'Angelo, Julian, if you guys are good with that, just kindly give me a quick GD chat, please, and thanks. If you need me to go with it again, give me a R, never know. All right. All right. So Zian, Jaziri, Diana, and Pedro, you okay with that one there? Yeah. All right. There goes Central Ladies. Any for Khalifa, Julie. You okay with that one? Any outstanding further questions, anything? Okay. All right. Okay. 6 part B now. Let's see what's going on here. Oh, wait, hold on just now. Let me send a picture of this one in the chat. Sorry. No. Right, back over. Okay, this piece here. Naya, please do. Sorry, I missed the question. Okay, let's take a look here. In the diagram below, points L, M, and N are on the circumference of a semicircle. What's a semicircle? Half a circle with center O and radius 18. So the radius is the straight line distance between the center of the circle and the circumference. So that will be 18. This here will be 18 as well. And what else? ON and OL. All right. So we have 18 here. We have 18 here, and we have 18 here. Now, what do I want? Calculate the total area of the shaded sections in the diagram. Interesting. So we have a semicircle. So imagine the whole semicircle was shaded, right? And they cut out the triangles, right? So when they cut out, does that imply addition or subtraction? Subtraction. So to find the area of what remains of the semicircle, as in those two what you call segments there, you want to find the area of the semicircle, the area of the triangles, the whole triangles, and then do what? Subtract. All right. Pythagoras. You could use Pythagoras. Yeah. Okay. So again, you want to find the area of shaded regions is equal to area of semicircle minus area of triangle. Right, so a semicircle is half of a circle. And what's the formula for the area of a circle? Pi by r squared. And what's the formula for the area of a triangle? Base by perpendicular height all over 2. All right, so I'll give you a couple of minutes. Any tips on circle theorem? I love circle theorem a lot. Tips, you had to know your rules inside and out, and you have to practice as many questions as possible. And always, always, always be on the lookout for if you have the center of the circle in the right place. What else, boy? Yeah, make sure you know where the center of the circle is if they give it to you. If not, then you keep just saying, aha, what's going on? Talk to me. MLK? You take a look now. MLK. So there's the whole angle there. All right, cool. So, do you happen to have this angle up here? No? Okay, cool. .48 would be the angle in the alternate segment. So that angle here would be 48 actually. Right? So you have 30 there. That's confirmed that that's 30. Right, so if you have 30 there and you have 48 here, you could add them up and then subtract from 180. Because you'll have 2 out of the 3 angles, not so? Right. So this is 48, which means that this piece here inside is 48. Yeah. No. Okay. All right, so we're still using pi as 22 over 7, right? So we have a half by 22 over 7 by 18 squared minus. So the base is the whole thing, the whole diameter, which is 18 by 2, which is 36. The height is still 18, and then we still have to divide by 2. So, well, the 2 will still cancel the 36 to 18, all right? So a half. So you had 18 squared on that side and a half by that by. Okay, cool. So you could actually factorize here. No need to, right? 2, that's 11 over 7. multiply by 18 squared minus 18 squared. Right, so really and truly, just plug it in your calculator. If you want to see something fancy, you could factorize. You could pull out 18 squared, which is 324, and have 11 over 7, minus 1. Right, now trust me. This here is pure, it's just me being purely idle, right? There's no need to show anything, right? So that's 18 squared, then multiply by 4/7. And same thing, I guess, just plug it in your calculator, right? So 18 squared is 324. 18 squared, 324. Multiply by 4 equal. Divide by 7. 185. Yep, there you go. 185 squared. 184.68. Yeah, that could work. Yeah. All right. Right, and again, you don't have to do these items here. You could jump straight from here to here. Right. That stuff in the middle is just me being extra, which you do not need to be in an exam. Of course, if anybody got any different values, let me know. Maybe I did something wrong. That's quite possible. Or maybe 11 over 2. 11 over 2, 11 over 7. Huh. I said 2 into 2 goes 1, and 2 into 20 goes 11 times. That makes sense, Yana? All right, Google Meet. You're on the new drill, right? So I should, yeah, Donovan and Julie. If you're good with this item here, give me a quick G in the chart, please and tongue. Cool. All right. Anissa, Khalifa, and Julie, we okay with this item here? All right. Zian, Jaziri, Naila, and Paige, we are with this one? Okay, cool. All right. Thank you, Shauna. All right, let me see. Else on YouTube. All right, let's see if we can make some headway. Number 7. Same 7, A, B, and C. 8 have a few parts too. All right, cool. Let me take a look. Number 7. Oh, 7 is a patterns question. All right. We can do this one, right? Usually I kind of bypass this piece. Let's just take a quick browse through. Diagram below shows the first 3 shapes in a sequence which forms a pattern. All right. Each shape is made using a set of small white counters and black counters. All right. And so this is to me what the maths is, because maths is study of patterns, right? And you get to explore what's going on here. Now, check this, right? In the first diagram here, we have how many black counters? That's 4, and then we have 6 white ones, right? And then it changes, right? It changes in that. Let's analyze the black, right? So in the black, we notice that this piece here kind of comes on the top here, right? And there's an extra row below it, right? Now, how many, okay, I know this is going to sound like a real silly question. How many black dots are in the top row here? 1. How many in the second row? 3. Now, if you're following that across, so you have 1 there, you have 3 there. How many in this row here? 5. 1, 3, and 5 is what kind of number? Sorry, they're what kind of? They're odd numbers, right? So in the next diagram, shape 3, how many black dots should we expect to see in the new row? 7, right? And if you look here, 1, 2, 3, 4, 5, 7, exactly, right? Sorry, Zine. Yeah, we've seen some odd stuff. That's correct. Lexi, all right, good job. Right. So the number of black dots, sorry, in every successive row, right, we have a new number of black dots, and the number of black dots is increasing by an odd number every time. Okay. Let's analyze the white dots now. All right. And yeah, that's correct. The next one will be 9. That's correct. Complete the diagram below to represent shape 4. That is pressure. To do shape 4, you gotta go across 1, 2 to get 9. Let me come out 1. Sorry. So it's not the neatest looking one. This one kind of out of place here. Right, and the white dots. Now, what has happened to the white dots? We didn't see, right? Let's take a look there. So we started off. So the number of white dots was always the same number of the black dots bottom row horizontally, but it was 2 down. All right. So same thing. So you had 5, 5, and 5. So now you had there was 3 and 3. So you had 2 rows of 3 and 3 rows of 5. So vertically, it's increasing by 1 every time. So here you have four rows now, and 3, 6, 7. Right. So you have 7, 7, 7, 7. Okay. This is an interesting pattern. I wonder what this would be, boy. It would be the total, but then that would be a quadratic, though. Yeah, because 1 and 3 is 4, 4 and 5 is 9. That's square numbers. This looks like squares. Let's check it. What's 1 plus 3? 4. What's 1 plus 3 plus 5? 1 and 3 is 4, and 4 and 5 is 9. And then you have 1, 3, 5, 7, right? 1 and 3 is 4. 4 plus 5 is 9. 9 and 7 is 16. So look at that. You have 4, which is 2 squared, 9, which is 3 squared, and 16, which is 4 squared. So the next one, you would have 9. Yeah, you would have 9, and the total number of black dots would be 25, right? Okay. So the total number of black dots is the pattern, I guess, x squared. But we can't use this. We have to use x plus 1. If we use this as x, you use x plus 1 because this is 2 squared, right? Okay, sorry. I jump in ahead. Varuni. And my brother's name is Varun. Anyhow. Right, sorry. Let's go to 7 part B. All right. So the number of white counters W, the number of black come on, man, Philip, do that. Black counters B, and the total number of counters T that form each shape follow a pattern. The values for W, B, and T for the first 3 shapes are shown in the table below. Study the pattern of numbers in each row of the table, and answer the questions that follow. All right, cool. So let's zoom in a little bit more, and then they want complete the rows marked 1, 2, and 3. So we could do row 1. I would then suggest let's go to row 3 and then backtrack and do row 2. All right, so this is not a straightforward one as in some of them, right? So if you look, to go from 6 to 15, that's an increase of 9. But to go from 15 to 28, that's an increase of 13. So that's not a straight increase, right? I would wager that it'll have a 17 here, but I could be wrong about that. Actually, no, 28 to 45 is 17, isn't it? So the increase is increasing by 4 every time. So yeah, so that's not a linear increase, all right? Anyway, so what was this here? 1 plus 1 squared, 2 plus 1 squared, 3 plus 1 squared. So if you notice, these numbers here match with these numbers here. So what would go in row 4? What would it say? 4 plus 1 squared. And what's 4 plus 1? 5. And 5 squared is 25. So like I said, the number of black counters was a square, but it wasn't these numbers squared. It was them plus 1 squared. So the pattern down here would be n plus 1 then squared. All right, 4. All right, cool. All right, total number of counters. Right, so let's see. Oh, look, they gave us the pattern here. So we could just use that to find that piece there. Okay, so what I want you to do, I want you to plug 4 inside of here. And then give me the value there. If it's 70. Right, so this was one of the kind of stranger ones. Not as straightforward as some of the others we've done, but again, not totally strange. They did kind of scaffold you through some of the way through. All right, so let's substitute 4 inside of that, right? What do we get? So we have 3 by 4 squared plus 5 by 4, then plus 2. So 4 squared is 16, showing us 70. I think it's 70. 16 by 3 is 48. 5 by 4 is 20, right? Now 48 and 20 is 68. 68 and 2 is 70. That's correct. Right. Now, we should probably find the pattern here. And to do that, you want to analyze going down, right? Now, what we should notice is that these ones stay the same, and the 2 in the front here also stays the same. But what differs? These numbers change. And what do they change in tandem with? These numbers here. So what that means is that each of these numbers corresponds to whatever this is, as do these numbers here. So the pattern would be n plus 1, n plus 1, then multiply by 2 by n, then plus 1. Right, so again, we looked at we looked at each of these, and we looked at what changed going from one line to the next, going down, right. Right, we also looked at that these stay the same, so it was always something plus 1, and in the second bracket, right, these items were each multiplied by 2 before we added 1. Right? And again, the things that change, as in these 1, 2s, and 3s, corresponded to these values here. So it was a n plus 1 by a 2 by n plus 1. Right? So if you check out the 4, it would have been 4 plus 1, which is 5, then multiplied by a 2 by 4, which is 8, plus 1, which is 9. And 5 by 9 is equal to 45. Okay, all right. So check what I want you guys to do now. I want you guys to find these, right? To find those, you're going to have to work backwards using either that or that, right? You should, I mean, we know that this is something squared, right? So you can work backwards there. So after you work backwards, don't forget, right? You have an adjustment to make. So it's not just the square root of 144, right? It's not just that. You have an adjustment to make to that. You'll find that value, and after you find that value, you can find that value there. Right, so let's zero in here. So n plus 1 squared is 144, which means we could find the square root of 144. That'll give us 12. Now that 12, is n plus 1, which means n is not 12, and is some number to which you can add 1 and get 12. What's the only number to which you can add 1 and get 12? 11, correct. So this value here is 11. And with that, now we can plug it inside of here to find, sorry, not there, my bad. Inside of here to find the missing value there. Right? So that would be 11 plus 1 multiplied by 2 by 11, then plus 1. Right, so 11 plus 1 is 12. 2 by 11 is 22. 22 plus 1 is 23. So 12 by 23. So that's 240 plus 36, which is 276. Anybody? Repeat. Yeah, okay. Right. Yeah. Cool. So again, let's just run it one more time. Right? So we know that this piece here is n plus 1 squared, right? Where this is n here. So the first thing we do is find the square root there, and we get 12. But 12 is equal to n plus 1. So to solve for n, you could subtract 1 from both sides, and 12 minus 1 is 11. So this value here becomes 11. All right, good job, Zane. Right, now, after you find that, you want you to find this piece here. And to do that, we could use this formula down here, which is n, 11, in this case, plus 1, then multiplied by 2 by n, which is 11, and then plus 1. So 11 plus 1 is 12. 2 by 11 is 22, and 22 plus 1 is 23. And then when you multiply 12 by 23, I do. This actually is one. This is just a recording I use as a backup to my major YouTube recording. But yes, I do. Right? 240 and 36 is 276. All right, cool. Okay. All right, ladies on this side, talk to them. Are we okay with what's on the screen there? Any questions, problems, queries? Get that? All right, cool. Okay. On far side, Zian Jaziri and Island Page, we okay with what's on the screen currently? Yeah. All right, cool. Google Meet. So I should be Angelo Donovan, Julie. If you're good, give me a G. If you need to re-explain any particular aspect, give me an R, please, and thanks. Oh, thank you. Yo. You gotta go now. All right. If you gotta go, what you gotta do? All right. Well, be sure to watch the remainder of the replay now. Last 20 minutes, right? The way you're messing with it. Okay. Okay. Is that 7 part C? Okay. The expression for the total number of counters T is equal to W plus B. All right. In shape S is given by that. Okay. Hey, Gabe, what's going on? All right. I'm gonna close the door. Okay. Right. Almost there, yes. All right. So the total number of count is given by this. Hold on. Sorry. So white and black. So we could just add these two things together. That's what you're saying? No, but they give it to us here, not so? 3n squared plus 5n plus 2. So how we get this other one here now? A s squared plus bs plus 2. But they gave us the thing. What are they trying to do? They're trying to confuse us? By substituting suitable values for s, show the total number of counters in shape 1 and shape 2 in terms of A and B is represented by these equations. Oh, right. So for those playing the home game and for those here, the total number of counters, right? You have black and white counters, yes? So the total number, so okay, sorry, diagram here. the total number of counters is this number of the black counters plus the number of the white counters, right? So they're using B for black and W for white. Okay, cool. But the thing is, they gave it to us in the table, not so? Right. So check what happened, right? So it's down to the bottom right there, the 3n squared plus 5n plus 2. So this is 3n squared plus 5n plus 2. But that's not what they want us to do, right? By substituting suitable values for S, show the total number of counters in shape 1 and shape 3 in terms of A and B is represented by those equations, right? All right, cool. Right, so check it. To find the number of counters, the total number, all you have to do is substitute the shape number. So if shape 1, the number is 1, right? So if S is equal to 1, then T is equal to A by 1 squared plus B by 1 plus 2. What's 1 squared? 1. What's A by 1? A. What's B by 1? B. All right. Now, they have A, and we have a plus 2 here, right? So how do we get to equal to 8? Now, if you go back to your diagram, right, and we count the number inside of here, how many we get? Yeah, the total number, that's 10, right? You have 1 on the top and a 3 by 3. You have 3 black and 6 white, so that's 6 and 3 is 9, plus the extra black is 10, right? So if we know that the number of the total number of counters is 10, right? And we have A plus B plus 2 is 10. And here they have A plus B is equal to 8. We had to move this 2, not so? And how do we move that 2? How is it attached on that side? Via addition. And how do we remove something by attached by addition? We use the opposite operation, which is subtraction. Or as people like to say, carry it over the equal sign and change the sign from positive to negative. Okay. So you subtract 2 from both sides of the equation. 2 minus 2 on the left-hand side will leave us with just A plus B. And 10 minus 2 is 8. And lo and behold, we get that. Right, now in shape 3, right, so if S is equal to 3, the total number of counters is A by 3 squared plus B by 3 plus 2. Now, if we go back to the diagram, we could count how many. Actually, it doesn't go to the diagram. We could go to the table. Look, see, 10. So come on. 24. And in shape 3, we had how many? 44. So we could just pull the number from there. That's equal to 44. Right, 3 squared is 9. 9 by A is simply 9A. B by 3 is simply 3B. And here we could subtract 2 right away. Right, plus 2 minus 2 is equal to 44 minus. So we have 9A plus 3B. 2 minus 2 is 0, and 44 minus 2 is 42. And here now, 9, 3, and 42 are all divisible by 3. 9A divided by 3 is 3A, 3B divided by 3 is B, and 42 divided by 3 is 14. And that's how we got that one there. Right. Okay. When you say private, you don't know, like, okay, my classes twice a week. Twice a week, 2 hours. By 4 weeks a month. As we go to 16 hours of lessons. Okay, and that was 2 marks, right? So that one, I admit that one was a little out there, right? So, and then you had to know to go back to reference the previous page to get the number of counters in each. So that one was a little, I wouldn't fight you with that one. But yeah, so again, you had to read the question, understand what they're asking you, Make sure you know where to pull the information from. Right. Okay. Okay. So Google Meet. So I saw only two of y'all answer last time. So right. So 8:50 now. So Aisha, Donovan, D'Angelo, and Julie. If you guys are good with this page, cool. If not, let me know. I'll do over the whole page. It's not a problem. Right. All right. Yeah, Nyland page. Are we okay with that page there? Questions, problems, issues, queries? Anybody, anything? You? Okay. All right. Hanifa Khalifa. Sure. Okay, cool. All right. So hold on. Let me just update my pics. One. Hey, Shona, thanks for sharing live so many times. I appreciate it. A little small. All right. All right, guys. So we have about 12 minutes again, and we now hit in question 8. So we'll see how much we can get to. But I think we're in a good position for Monday to wrap up this paper. And yeah, 3 days is enough for a paper. Okay. Algebra, relations, functions, and graphs. Right. So the diagram below shows the graphs of two functions on the same pair of axes. The lines G and H are perpendicular. Okay. Perpendicular has a sorry. When it says that two lines are perpendicular, what does that mean? What angle do they meet at? 90 degrees. Hence that little 90-degree angle thing right there. And there is a particular relationship between the, yeah, sure, that's correct. Very good. Between the gradients of perpendicular lines. If we let the, okay, so we have line G and line H, right? So the gradient is given by small m. So if we take small m and put a G, that's the gradient of line G. And if we multiply it by the gradient of line H, we get a -1 value, right? So that is the relationship. The product of the gradients of mutually perpendicular lines is equal to -1. Now, what that means is if we have the gradient, for example, of G, we could find the gradient of H by simply dividing. So the gradient of line H is simply -1 divided by the gradient of line G. Right, now, the first thing I want is the equation that represents line G. All right, so what do we know as the equation of a straight line? Y equal to m by x plus c. Right? Where m is the gradient. Right? So that's G, right? So the gradient is equal to the difference in the y values, y2 minus y1, over the difference in the x values. And c is the y-intercept. Now, the interesting thing here is if you follow line G, we could see exactly where it passes through the y-axis. So we already know the value of c. It's 3. So all you guys have to find here is the value of m, the gradient, right? And you could use these 2 points, the 2 intercept points, right? So this point here, that's c. Let's call this point here, let's just call it d, right? So the coordinates of c, because it's on the y-axis, is 0 and then 3. And the coordinates of d are -6 and 0. So you could use these 2 pairs of points to find the value of your gradient and then just chuck it in the equation there with, what you want to call it, the value of c. All right, so find the gradient using these coordinates here, and then substitute it in place of here with the value of 3 for c. All right, so find the gradient. Let's start there. Gradient, this formula here, using these things here. hardware. Let's take a look and see what that means. Where? Oh, really? So who have the whoa. That is pretty cool. Right, so we have 0 minus 3, y2 minus y1, all over x2 minus x1. So we have minus 3 over minus 6, and a minus divided by a minus is a plus, right? So we have a half. So the equation becomes y is equal to 1 half x plus 3, right? And that's all on that page right there. Yeah, that's it. Lizard. Out and bad. Lizard Carnival finished yesterday. We in Lent. Give up being lizardy in my class. Right. Okay. All right. Google Meet. I know you just give me a G, but just give me a quick G dinner, please, for that one. If you guys good with the equation. Thanks. Cool. All right. Let's just take a quick peek at the next page real fast, right? Now they want the equation that represents line H and the coordinates of P. Let's take a look and see what's going on there. Equation that represents H. All right. Now let's put H in the green, right? So the only point that we have for H is this point here. Let's call that point. No, we can't call it G or H. Oh Lord, have mercy. I can't find a letter. Let's call it point A, right? The coordinates of point A. Now, because A lies on the x-axis, it means that the y coordinate is 0. Right? So we have an x value and a y value. And again, two lines are perpendicular. So we would need the gradient of h. And we said if we have the gradient of g, we could find the gradient of h by simply doing what? Right? Gradient of h is minus 1 divided by the gradient of g. Right? So that's equal to minus 1 divided by, and what is the gradient of g? A half. Right? And when we divide by when we're dividing by a fraction, what's the protocol? Change divide to multiply and invert the fraction. And what's minus 1 multiplied by 2? Minus 2. Right, so on this side now, right, so again, we're going to use y equal to mx plus c. Now, as m each, right? And again, we're going to say that the gradient of line H is equal to minus 1 over the gradient of line G. right? And we could say using coordinates of 4 and 0, because those are the only coordinates we have with respect to line H. That's the only one that we have, right? Right, so y, which is 0, is equal to minus 2 by 4 plus c. Minus 2 by 4 is minus 8. And to solve for c, just carry across the minus 8 and change the sign. And therefore, we can state categorically that y, the equation of h is y is equal to minus 2x plus 8. Okay. Now, they want the coordinates of P. What is that point P? And with respect to the two lines, that's where the two lines meet or intersect. And to solve for a point of intersection, you have to solve the equation simultaneously. All right. So the equations are y is equal to a half x plus 3, and you have y is equal to minus 2x plus 8. Right, so I'll give you a couple minutes to solve that. I don't know that we'll get to part B. What is part B? Okay, we could pick up with part B next time, but I would have liked to have done it today. I don't know how come that first question took so long. All right. Yeah, sure. We explain part 2. Right. They want the equation that represents line H. Right. Now, on the previous page, line H is perpendicular to line G. Now, sorry. What that means is that the product of their gradients is minus 1. So it means that to find the gradient of line H, to find the gradient of this one here, all we have to do is take minus 1 and divide by the gradient of G. Now we have the gradient of G from before, that's the 1/2. Right? So you divide minus 1 by a half and get minus 2. Now, again, they want the equation of line H. The equation of a line is simply given by y equal to mx plus c. So we need one pair of coordinates. The only coordinates we have for H is this point down here, which is point A, and A has coordinates 4, 0. Right? Now, from there, yeah. So again, the equation of a straight line is y equal to mx plus c, where m is the gradient and c is the y-intercept. To find the gradient of this line, because we know it's perpendicular to the previous line, we divide minus 1 by that other line's gradient, which is a half. And minus 1 divided by a half is minus 2. The only point that we have along the line for which we're trying to find the equation is 4, 0. Sorry. So we substitute now. So this is the x coordinate, that's the y. So y is equal to m by x plus c. And we substitute, simplify, and solve. Minus 2 by 4 is minus 8. Minus 8 plus c is 0, so c has to be 8. And then you simply restate the equation in this same form here, y equal to mx plus c. All right, so I hope that helps. Okay, down here now we can do some, so you could put them equal to each other, or you could just subtract right off the bat here, right? Y minus y is 0. A half x minus 2x. So when you minus and minus, it becomes a plus. So 2 plus a half is 2.5x. 3 minus 8 is minus 5. Okay, interesting. So what that means is 2.5x minus 5 is 0, which means if you bring across the minus 5, it becomes plus. I hate to explain it that way. And then if 5 is equal to 2.5x, to solve for x, you divide 5 by 2.5, which gives us a value of 2 for x. Now to solve for y, you could use either of these. Let's use equation 1. So y is equal to half x plus 3. A half of 2 is 1. 1 plus 3 is 4. Therefore, the coordinates of P are simply 2 on the x and 4 on the y. All right, you could also put these two equal to each other. You'll still end up here. It'll just take a little long. All right, so folks, right, we got through a good bit, right? I would have liked to have gotten to 8 part B to finish off 8, but we can knock that out pretty easily on Monday. All right, let me just send a picture of this in the chat real quick. Okay, so folks, that's about it for today, right? I'll send a link to the replay in the chat. I sent the stuff as we went along there. I'll probably still create a PDF and send it to you, right? So if anybody has any questions and they get to ask during class, please feel free to WhatsApp me. I think my WhatsApp is working a bit better now, right? Apart from that, have a good weekend and I'll see you all next week. Bye. Yo. Sorry? Oh, yeah. All right. Hey, Angela, sorry, I didn't see your message. Any relation to Cheryl? Alipop? You still remember? Yeah, what you can do, Angela, you gotta check your settings on your side. It's showing clear on mine. So check the little gear, the little settings icon on the YouTube video, and you could change it to like 1080p or whatever the case is. Anyhow, I had to go.